Hello everyone, I will show you how to calculate power from the intensity plots that you have taken. So here I have an intensity plot. This is not an actual image, this is just a computer generated image that I have, and this is what your laser beam spot would look like if you don't have the knife edge placed in between. Once you put the knife edge, then the image definitely will change, it will get distorted. So this is the laser beam spot that we have, this top image. And what power is basically given as the area integral of the intensity. So Ix comma y, and then you integrate over dx dy. This will give you power. And so this image is just Ix comma y. So this is your x-axis, this is x-axis, this is y-axis, and each point will have some intensity. So this pixel over here will have some Ix naught y naught value, and you need to find out the area integral of this. Now if I look at this image in 3D, then what will it look like? So I have x-axis, then I have y-axis, and on the z-axis I have plotted Ix comma y. So for a given x, say this point, and for a given y somewhere over here, if you go, then this would be your corresponding intensity value. Okay, so now in this 3D curve, power, as we have written over here, is this thing. So power is basically volume under this surface. So let's say I am at this point, then I will draw a dx, a dy, and then I is this from the z. So if you find out the volume of this, then that is one element of this integral, and if you just sum it over, so we can approximate this integral as a double summation also. So this is a double sum of I at some pixel x, some pixel y, and then multiplying it by whatever the pixel width is in the x and y directions. So this is the discretization of the integral. And so basically what you need to do is, if you look at the 2D image, this 2D image over here, then what you need to do is a weighted sum. Why I say a weighted sum is because each point has one of these values of intensity, and you need to sum all of them with this basically calibration in the x and y directions for the length. And if you look at the 3D curve, this is 3D on the bottom, then it's basically like the volume under the surface. So this is the laser spot. Again, this is the computer generated beam. I have made it green, so it's like a green laser spot that you would see on the screen when you do not have the knife edge. Now we will try to find out the total intensity, that is the power in this intensity of the laser beam, by using Python and ImageJ. So first I will show it to you in Python. So here is the Python code. Now it's a very simple code. You just have to import two packages, namely matplotlib and numpy. This line is reading the image. I have saved that image as laserspot.jpg, so I'm just reading that image. This one I'm just plotting that image to see that the image is the same image that I want to load. And this line is RGB weights. So we want to convert the colored image into a grayscale image, a black and white image. So this is the weights that would basically convert it, because you see RGB is three numbers: red, green and blue. So each of these red, green and blue will have certain values from 0 to 255. But we want to convert this into a grayscale which has a single number from 0 to 255. 0 meaning black, 255 meaning white. And then this line where it is a gray equal to np dot dot. So this will just take a dot product of your image with this weight conversion to convert the colored into a grayscale image. And finally, I'm plotting that grayscale image. This last line is summing up all the intensity values. This is what will give your power essentially. Of course, you will have to multiply this with the scaling factor, scaling meaning the delta x and delta y, what your length in the x and y directions are. So that you would have to do. If you take the image at the same magnification, which means that your screen and your camera are kept at the same distance always in all the images, your camera is at the same distance from the screen, then you would get rid of that scaling factor, because then it would be the same throughout in all the images and you can just take it as a constant term. So yes, now let us just run this code and see what happens. So these are the plots. Actually, this is the original green laser spot image that I had, and this is the converted black and white image, and here is the sum value, that is summing up all the intensity values in the image. So this image is there, you see. If I add all the intensity values, so here let's say it is very bright, let's say this would be something around 170, this one would be 0, so you add 0 0 0, then let's say this one is 20, so then 20, then you keep adding all these terms and you will get this value. So this is how you do it in Python. Now let us see how to do it in ImageJ. So yes, this is the ImageJ window. First things first, let us load the image that we want. Select local file. Here is that image where I have saved it. So this is the laser spot image. And again, we need to convert this into a black and white. How do we do that? First go to edit, then options, then go to conversions and check both of these. I've already checked them. So this you see is weighted RGB conversions, and this is the same conversion formula that we use in Python. Of course, they have rounded it off to 2 decimal places. If I just open Python once again for you, you will see the same conversion formula. You see in line number 16, RGB weights are 2.989, sorry, 0.2989, 0.587 and 0.114. So same, these weights are over here. Just set OK. Now you go to image, select the image, this image, then go to image, type and do 8-bit. So this will convert it into a grayscale image. Now you go to analyze and histogram. So this histogram is basically saying that for intensity 0, that is black, how many pixels are having black, and for intensity 255, how many pixels are having 255, and all the values in between. You just press list over here. This will give you a list. So pixel, so this is pixel count, count is their pixel count, and this is pixel intensity, this is value. So this is basically a count versus value. So you see for 0 intensity, that is black, there are 3711 pixels. As you can see, there are so many black points over here. Then 1 is also very close to black. So there are 8256 pixels with black. So you see majority of this is black only. And if you go down, you will see increasing intensity values and the pixel count corresponding to them. And over here you see 162, that is the maximum. So this centermost point where there is maximum intensity, there are 2 pixels with that, and the value for it is 162. Now you simply save this file. It will say save it as a CSV file. Yeah. Now save this as a CSV file. So you just click save. So save it in downloads. Just save it. And then you open this. It will automatically open in Excel. Now you need to do a weighted sum. So intensity 0, these many pixels, plus intensity 1 times these many pixels. And you do that by saying just write equal to, select this into the count. So value into count. And of course 0 into 3711 will be 0. Now you just go to the end of the cell, a plus sign will come, and then you drag it down all the way down to 255. Yeah, here. And then you see they have computed, this Excel has automatically computed the product. So 1 into 8256 is of course 8256. 2 into 2903 is 5806. Then you go down to the bottom and we need to sum up all these values. So you say equal to, then write sum, select this, and then select all the values that you want to add up. So you just select all these values all the way to the top and then press enter. So this will give you the sum of the values. Now you see this sum 1479952, and if we see the Python sum, that is 1481375. So slight difference is there, because you see if we round off the RGB conversion weights, slight difference will come up. And if you use only one software, either ImageJ or Python, and be consistent with it, then that will not be a problem, because it will be same throughout in your experiment. So this is how to calculate the total power, that is total intensity, which will give us power. But you know, I always mention that we should calibrate. We need to know what each pixel is in terms of length, say millimeters. Now how do we do that? Again, I will go back to my ImageJ. Here is my ImageJ. And one idea that I have, which you can follow, of course you can have other ideas, is that when you take an image, after taking the image of the laser beam, you place a scale on the screen and then take an image of the scale at the same distance. So your camera, your mobile phone, or whatever you're using as a camera should be at the same distance from the screen. Once you take the image of the laser spot, next time you place a scale at the screen where the laser spot is, and then you take an image. So in this image, this is a computer generated image, so I don't have the scale. So you, in your image, you might have a scale somewhere on the top. And you see this image is basically 252 cross 207 pixels. And your scale would be somewhere there. So let us select the line tool and let us draw a line. Let us imagine that there is a scale over there and we are drawing this line across that scale. So you see length equal to 70 pixels is showing in the ImageJ toolbar. So you just draw this line across the scale that you would have. Then you go to analyze, set scale. Okay. So you see this is 70 pixels in length, the line that I have drawn. And let us say the scale is over there, and let us say in the scale it shows 1.5 mm. Sorry, 1.5 mm I cannot have, because the scale least count is 1 mm. Let us say this shows me as 2 millimeter. Of course, this is a very hypothetical case. You would have to figure out how much distance is there in your experiment. And this unit, let us say millimeter. Okay. So now 70 pixels is basically 2 millimeter. Just do enter, and automatically you see this has calibrated now from pixels to millimeters. So 252 cross 207 pixels has now become this 7.20 into 5.91 millimeters. Now we see from the length calibration that 70 pixels was our 2 millimeter. So you can find out what 1 pixel is in terms of millimeter, and that will be your delta x and delta y. And this is how you would do the calibration. Another way of converting an image to black and white or grayscale is, this is for Windows 10. Now you open the image and go to edit and create and select edit. Now in edit, you go to adjustments and set your color all the way down to -100. Once you do that, your image will automatically be converted into black and white grayscale. But notice this will work in the ImageJ. This grayscale image would work fine with all the histogram calculations in ImageJ. In Python, you would still have to do that RGB conversion, because Python treats each image as a 3 value, R, G and B, red, green and blue. So you would have to convert each this red, green and blue array into a single number from 0 to 255 using the dot product that I showed.